down 271 div 2 f. So in this question, we are given a array A. Here it is called S. Let's call it array for the sake of the question. We've been given an array and we have been given q queries. Each query is of the form L, R. In each query of the form L to L, R, we need to find the number of elements in L to R, in the range L to R, such that the GCD such that all the elements in the range L to R are divisible by uh, the element under consideration. So if we need to find the number of such elements I, where I is element of L to R. We need to find such elements, number of such elements I, such that AI divides all AJ in the range L to R. This is the question. So yeah, this is the question. Now, what we can reduce this question to is that if AI divides all the elements in the range L to R, what this basically implies is that AI would be a multiple of GCD of L to R. So, uh, so would be that AI GCD of L to R of all elements in the range L to R is a multiple of AI. Yeah, this fact can be deduced from this statement, and from and also we know that AI also lies in the range L to R. That is lies in the range L to R. So from this, we know that GCD of L to R cannot be greater than AI. It has to be lesser than equal to AI. So from these two inequalities, we get that GCD of L to R should be equal to AI. Okay. Now we need to so the reduction of the query, and the query can be reduced to this query, where given L to R we need to find the number of elements in L to R such that AI is equal to GCD of that range. Right. Now GCD of any range can be calculated very easily using a segment tree. So given L to R, we'll be able to find this in order of log n. Now the question is how do we calculate the number of elements in L to R that are equal to a certain key. Now the way I have done this, where key here is the value of GCD from L to R. The way I have handled this is I have maintained a map of int comma vector of int, where MP of x is a vector of indices where x occurs in the array, and the number of elements in L to R which are equal to key is nothing but we first find the upper bound of R and then lower bound of L. Yeah, this is the question, this is the solution. Now moving on to the code. Code is pretty simple, pretty straightforward. This is building the segment tree. This is the merge logic of the segment tree where T of index stores the GCD of elements in the range. Leaf logic is pretty simple, where the GCD of the leaf is the value of the leaf itself. For query, again, it is very simple. Right. Thank you.